Okay, can somebody explain why number 6 is none? Why is number 6 none? It looks to me like you could do, you've got a side right here, you've got a side right here, and you have an angle. So how come you can't do angle, side, or how come you can't do side, angle, side?
Because it's not connected.
Bianca?
The angle's not in between.
The angle's not in between. What's the word we use for the angle that's in between? It's called the included angle, right? So this isn't the included angle. And we can't use angle, side, side, because that's not a thing, right? And neither is SSA, all right? So that's not a thing, okay? No. Because it's not enough to prove that the triangles are congruent.
Can you make it like yourself?
No, because if you have one angle and two sides, it's possible for the other side to be different. So it's not conclusive enough to make it congruent triangles. So it's not enough information if the angle is not the included angle. Okay, so that's all leading to, that is all leading to what we're going to talk about today, which is CPCTC, all right, which is an abbreviation, so you don't have to write this all out all the time. That means corresponding parts of congruent triangles are congruent. So basically what that says is this. If you have this triangle ABC and this triangle DEF, if I tell you that ABC is congruent to DEF, ABC is congruent to DEF, what are some things that you could tell me? What other things could you tell me? If ABC is congruent to DEF, what are some things you could tell me? I can think of 6. So can somebody give me one thing that is true if I tell you that the triangles are congruent? AB is congruent to DE. How do you know that? What do you mean by they're on the same line?
But different triangles.
Okay, so they're in the same position in the different triangles. So AB is this spot, this top spot. DE is in the same spot. We call those what? What's that long C word? They're corresponding parts. So AB corresponds to DE. Therefore, if the triangles are congruent, this is congruent. Okay, what's the second thing you can tell me? What else could you tell me? Gabriel, what's one more thing you could tell me? Angle A is congruent to angle D. Good. Give me one more thing. Rosie, give me one more thing you could tell me. C is congruent to angle F. All right, give me another thing. Melanie, give me one more thing you could tell me. BC is congruent to EF. And give me another thing you could tell me, Mariah. AC is congruent to DF. And then what's the last thing that you can tell me if you know that those triangles are congruent? Rebecca? B is congruent to E. Good. B is congruent to E. So if you know that triangles are congruent, you can prove all 6 of these things. So you can prove that every side is congruent to its corresponding sides. And that's what this is right here. That's what CPCTC is. That corresponding parts of congruent triangles are congruent. Okay? So once you prove that triangles are congruent, you can then use that to prove that any other missing parts that you don't have are also congruent. Bianca?
I was going to say, so if they give you that incongruent,
Then you can use CPCTC. All right, but you can only use CPCTC once you know that the triangles are congruent. So think back to some of those practice proofs that you guys did on Tuesday in the second block. You know how in some of those proofs they asked you to say, like, prove that an angle was congruent to another angle as the last line of the proof? That's when you would use CPCTC, okay? All right. Miguel, can you put that away? All right, so take a look at this right here. To design a bridge across a canyon, you need to find the distance from A to B. Locate points C, D, and E as shown in the figure. If D is equal to 600 feet, what is AB? So if DE is equal to 600 feet, I'm going to label that 600 feet. And I need to find the distance from A to B, because I want to build a bridge across this canyon. What can you prove here? What can you prove looking at this? Does everybody see the two triangles that are here? Okay, so there's triangle DCE and triangle ABC. What can you prove? Go ahead, Charlize.
DC is congruent to CB.
Good. DC and CB are congruent. How do you know that?
This is both 50/50.
Good. It's written there, right? So we would call that a given.
So technically we're kind of doing a two-column.
Yeah, we're doing a two-column proof just from this picture. That's a given. What else were we given? What else are you given there? Bianca?
C is the midpoint of D.
Okay, we know that. Yeah, that's true. We could write that. We might not need that. Mariah?
Angle D and angle B are right angles.
Angle D and B are right angles. So angle D and angle B are right angles. And that's also a given because it's drawn in the picture. What else did they give us? What's our last given? DE is 600. All right, so what else can I prove? What else do I know? Just based on that picture, what else do I know? Vertical angles. There's a pair of vertical angles in there. What are they? DCE. Because again, you've got to say the vertex in the middle. So DCE and ACB are congruent because of what? Because they're vertical angles. All right. So do I have enough to prove these triangles are congruent yet?
Yes. No. Yeah.
I'm not sure. I know that I have this angle and this angle, and I know that I have this and this. What do I know about these two angles? They're right angles, which means they're also what?
90 degrees.
They're also 90 degrees, which means those two angles are congruent. They're both congruent because so angle D is congruent to angle B. Why? Definition of right angles. They're both right angles. They both must be 90 degrees. All right, so now I know that these two angles are congruent. So do I have enough to prove the triangles are congruent now? Yes, using what property? ASA. Very good. So I can say that triangle DEC is congruent to triangle ABC.
What's RT?
Based on ASA. What'd you say?
What's RT?
Right angles.
Oh, okay.
Yeah. So now that I know that those triangles are congruent, now what can I say? Bianca?
D equals,
Yep.
AB
AB equals
equals 600.
600. So now I can say that 7AB is congruent to DE, and that's based on CPCTC. And what is that again? CPCTC. Corresponding parts of congruent triangles are congruent. So now that you know that they're congruent triangles, now you can say corresponding parts are congruent. So that means if DE is congruent to AB, then what is AB? 600. Must be 600 feet. Okay, so that's how we found that, because once you've proven the triangles are congruent, that's when you use CPCTC. So you can only use this once you've proved the triangles are what? Congruent. You can't use CPCTC until you know that. Okay, I want you guys to try this one. I want you to try this one at your boards. Okay, so let's take a look at another one. All right. So what is in our picture here? What does this look like? Yes, it is a table. Above the table, in the figure, what does it look like?
A rectangle.
It looks kind of like a rectangle, okay.
Two triangles.
Two triangles put together to form, it's a parallelogram. All right, this is a parallelogram. So we're going to say it's not a rectangle because it's slanted.
But it's closer than a square. It's like a rhombus. Squares are.
It's a parallelogram, all right? But it's a parallelogram that's cut in half to make two triangles. So what are our givens?
EG is parallel to DF. EG is.
And what do I want to prove? ED is parallel to GF. Okay, good. So ED is parallel to GF. All right. So I know that these two sides are congruent. What else do I know?
You know that DF and EG is parallel.
I also know that DF and EG are parallel. So I'm probably going to use what, Rebecca? I'm probably going to use two interior angles to find that they are congruent. So if these lines are parallel, what angles could I say are congruent? EGD is congruent to GDF. Good. EGD is congruent to GDF. Angle EGD is congruent to angle GDF, and that's based on alternate interior angles, which you can use because these two lines are parallel. If it did not tell you that they were parallel, could you use that? No. Okay, so only if they're parallel. All right. No. So is there anything else that you know? GD is congruent to GD. And that's based on reflexive. All right. Do I have enough now? Pretty sure. Pretty sure I do. So what triangles can I say are congruent? EGD is congruent to FDG. FDG. And that would be based on what? Not yet. Hold that thought. I'm going to come to you later for that, but not yet. All right. Side angle side. Why can't we use CPCTC yet? We don't know the triangles are congruent. So first we have to prove the triangles are congruent. We just did. So now what else could I say? Well, that's not what I'm trying to prove. I can't prove that it's parallel yet. I can prove that it's congruent. I know that.
You have to do E is congruent to F.
E is what?
Congruent to F.
What, E and F, like the angles?
Wait, no, but couldn't you do alternate, inverse of alternate exterior?
Not inverse of.
What is it? It's like that.
It's like inverse, converse of. Okay, so I can use converse of alternate interior, except that if I'm talking about these two parallel lines, or if I want to prove that they're parallel, I can't use these angles. Which ones do I need? I need this one, DGF and EDG. So I can say 6, I can say EDG is congruent to DGF based on what, Miguel?
The corresponding parts that could congruent triangles are congruent, which means
That's so much to write.
CPCTC.
Thank you.
You're welcome.
CPCTC. So that is CPCTC. And now that you know that those are congruent, then Gabe said I can use the converse of alternate interior angle to prove that ED is parallel to GF. All right, I can prove that those are parallel using the converse of alternate interior angles. Okay, so that would be one way that you could use CPCTC in a proof. All right. I do love two-column proofs. I do. All right.